In this section, we'll cover the Mesos configuration that you need to build in order to provision a cluster to do health check metrics on your Express application running a Node server with a zookeeper abstraction. In this case, we'll be using React Router, which is a React library that allows you to do dynamic routing between objects in nested classes inside your application. Usually, when you're using Rails or Ember, you're doing static routing, and it encompasses an idea of having listeners turned on and having specific functions or elements broadcasting a message beforehand as a constant. Dynamic places a boilerplate instance of an object and transmits live and constantly changing by the second or nanosecond, depending on the metric of interest. Everything we do can be compiled using npm. So this is just a snapshot of what the React Router package JavaScript object looks like, and this is how you would implement a dynamic routing friendly example where you're treating these instances as elements in a stack. This can be anything from a navigation bar to a status bar. In essence, what we're doing is we're building a zookeeper instance, and a zookeeper instance takes care of the nodes and establishing a leaderboard. We can consider nodes to be either static or dynamic, but in this case we will assume that most of our nodes are transmitting and broadcasting on the fly, and we are parsing and ciphering the bit streams using a zookeeper redirect JavaScript class, and the middle layer is composed of React Router, which takes care of defining the finite state machine of the streams themselves. In this case, we have a route instance, a default route, and an NAN or a not found route. The zookeeper client object is an application that needs to pass a connection string which contains a comma-separated list of host port pairs, each corresponding to a zookeeper server. And the gist of this zookeeper service is pretty much that of an application that must be instantiated, and all iterations forthcoming should be done by calling a method within that zookeeper class. And once a connection to a server is established and a unique number is provided, or a session ID is assigned to the client, we can call this as a route ID or the default route. All of this inheriting from the React Router library that can be installed using npm. Now, if for some reason the client fails to send a heartbeat or a signal to the server for a specific amount of time, one that exceeds the session timeout value, for instance, then the server will expire the session, and then the session ID will become invalid. The client object will no longer be usable, and you need to remember that when you practice something akin to garbage collection, it can have an effect on the latency of the querying whether you decide to persist that information using a database locally, but we're not there yet. We're just building this information pipeline that will broadcast information from the Mesos cluster into a server that will transmit specific metrics and units of measurement to gauge and counter the state of the Mesos cluster. And the best way to do this is by using a zookeeper masking class or a zookeeper redirect instance. And we're going to do this under the routes folder inside your source folder, where you will find the entire application. A client needs an object of a class implementing a watcher interface. A watcher interface, as it sounds and in terms of a semaphore, is pretty much an agent that checks the state of the server it is probing. The watcher interface for processing the events delivered to the client are assessed in a first in, first out priority queue structure. The session is established asynchronously. By this, we mean the constructor will initiate a connection to the server, and each connection is going to be treated as a children or an adjacent list. From that, we gather there are a set of heuristics embedded in the JSON data that need to be routed onto a URL, which is deeply linked. And we're going to touch this in the next section, where by using deep linking, we're only requesting and broadcasting a specific section of a URL, like a port parameter, that makes the rendering far more efficient, where certain attributes do not have to be broadcasted. We only want to get the main listeners from the zookeeper list and probe the listener or the endpoint. For this, we have to check if indeed there is a connection, and an instantiated connection will be one where zookeeper picks an arbitrary server from the connect string, and once we know it's connected, we expose the listeners. In return, after sorting this list and finding the smallest value, we broadcast a message including the membership, the instance and its position in the array of listeners. SuperAgent and Lodash, which are amazing JavaScript libraries, were able to concatenate and partition sets of data, so it becomes part of this very rich streaming API, which takes care of the cleaving or the sheafing of metadata that's useful for us and sending or emitting that package Again, we specifically want to broadcast our message and send it as a component, and that component is merely a URL that is deeply linked to a port assigned, via Zookeeper or a Mesos endpoint, and it calls a specific set of static classes or static elements of HTML and others which are attributes that are changing. Because we're building a dashboard, we must understand that we need data such as CPU, memory, and we need other information that remains a constant. Within that dashboard, we'll have buttons. They won't request the same amount of information as a D3 visualization or graph. So for example, for CPU usage, we're using a donut geometry or a torus with different gradients of colors to symbolize how much CPU we've used, geometrically speaking. But the buttons themselves and the widgets are constant or static. They must only request and take a specific set of information. And this is why you're going to notice why there is a templating going on. I'm going to reuse this boilerplate.